This is problem 24 of 10.3. In this problem, you're asked to find the indefinite integral from 4 to positive infinity of x plus 18 over x squared plus x minus 12 dx. So the first thing you're going to do is you're going to write this as a limit. So what you do is you keep the 4 there, you change infinity to t, and you take the limit as t tends to positive infinity of 4 to infinity x plus 18 over x squared plus x minus 12 dx. Now you need to solve this integral, so you need to do this definite integral over here. So again, whenever you get to an integral, the first thing you should be thinking is, can I solve this integral using the u substitution? So if you were doing the u substitution, your u would be what's in the denominator. That's x squared plus x minus 12. So look at that and then say, okay, what's the derivative of that? Do we have du up here? So the derivative of x squared plus x minus 12 is 2x plus 1. We don't have 2x plus 1 up there. And we don't have a multiple of it, so u substitution isn't going to work. So next thing you think of is, can we factor the denominator and use partial fractions to solve this? So let's look. X squared plus x minus 12, so two numbers whose product is negative 12, whose sum is 1, and that is x plus 4 times x minus 3. So that's how we can factor the denominator. So let's do the partial fraction over here, and we get x plus 18 all over x squared plus x minus 12 equals a over x plus 4 plus b over x minus 3. So you take the common denominator here, you need to multiply by an x plus 3, x minus 3, sorry, so you get a x minus 3 over x plus 4 x minus 3 equals plus b times, now here you've got the x minus 3, so you need to multiply top and bottom by x plus 4 all over x plus 4 x minus 3. And so what you do is you say the denominators are the same, so the numerators have to be the same, so you get x plus 18 equals a x minus 3 plus b x plus 4. And you can make the choices for x so that it'd be easy to find a and b. So the first choice that you should probably make is x equals 3, so substitute 3 on both sides. So on this side, 3 plus 18 is 21 equals a. 3 minus 3 is just 0, so we get rid of this. And we say b, 3 plus 4 is 7, so we get 7b. So therefore the value for b is equal to 3. Now let's do the same to find the value for a. So this time let's substitute x equals negative 4. Because if you substitute negative 4, you get rid of this one. So you get negative 4 plus 18, which is 14, equals a times 4 minus 3 is 1, so we just get a. So there's the value for a. So now we have the value for a, we have the value for b. So there's a, and there's b. And so what we can do is we can just go and now solve the integral. So let's do that. Make this up a little bit. Send the page. Okay, so we have that. Let's go bring the integral problem up again. So here's our problem. Bring it down over here. And so this integral is actually equal to the limit as t tends to positive infinity 4 to t a, which was 14 over x plus 4 dx plus b. I'm going to put this bracket over here. So that's the integral from 4 to t which was 3 over x minus 3 dx. Let's close our bracket. Let's do the integral first. So we get the limit as t tends to infinity. This is just going to be ln, right? Because we've got, if you take this to be your u, then you get du, so you get du is just dx, so you have that 14 there. Ln of absolute value of x plus 4 from 4 to 2 plus, and this is ln of absolute value of x minus 3 from 4 to 2. And you're going to take the limit right at the end. So let's substitute t in first, so we get the limit as t tends to infinity. 14 ln of t plus 4 minus ln of 4 plus 4, which is 8, plus, I'm going to go back to here, ln of t minus 3 minus ln of 4 minus 3, which is just 1. Okay. And recall that ln of 1 is 0. So let's continue. So here we get, let's write this all as 1 ln. So the limit as t tends to infinity of ln of t plus 4 minus ln of 8, 14 times that. This would be ln of t plus 4 over 8, so we get 14 ln of t plus 4. But since t is going to positive infinity, we're just going to get a positive number, so I can get rid of that absolute value sign. Plus ln of, and the same over here, so we get t minus 3. And ln of 1 is 0. So we can just forget about that and just write this as ln of t minus 3. Now, this 14 can come inside, and this, since it's multiplied, it goes up here, so we get the limit as t tends to infinity of ln of t plus 4 to the 14. Did we forget that 3? Yes, we did. So there's a 3 here, and there is a 3 over here, and a 3 over here, and a 3 over here. So we get ln of t plus 4 to the 14 times ln of t minus 3. Well, actually, you don't need the ln anymore, because we're multiplying it. So this comes out to ln of t plus 4 to the 14 times ln of t minus 3 cubed all over 8. There's no ln here. I put that ln there. There again. Okay. Alright, and so now what do we have? So this, as t tends to infinity, we get infinity times infinity, which is infinity. Ln of infinity is just infinity. So therefore, our final answer is equal to infinity, and so we can say that the integral is divergent.